So we'll be talking about Vayu, the Airflow Copilot. With that, let's get started. So I will start introducing ourselves. So myself, Muhammad Ishaq. I've got a total of 13 years of experience, primarily working on big data domain. Currently, I'm working as a big data architect at Prevalent AI. So I'm part of the data fabric team here, where we have a product called Data Fabric, which basically has a module to ingest data from any cybersecurity data sources called data bridge. And then we have a module for this Data Fabric product, which is called Knowledge Graph. So from all of this cybersecurity data flows, we create something called Knowledge Graph. Okay. And then the platform has the capability to build applications of product on top of this knowledge graph, which gives cybersecurity insights to our end users. That's primarily the Data Fabric product does. So I'm looking after the key architecture of the Data Fabric component product. So recently I've been involved in an initiative called starting from the ingestion to preparing the knowledge graph to make our whole data fabric agentic. So the thing which we are going to present here is Vayu, which is basically a thing which we got inspired from those initiatives. So that's just a prototype which we have built by analyzing different tools and things from this agentic data fabric initiative. So that's pretty much about myself. Sanjit, over to you.
Yeah, hey everyone. My name is Sanjit Srikanth, and I am a senior data engineer at the platform engineering team at Prevalent AI. And I have helped build this cloud agnostic data platform, which Irshad was talking about. And for the past 4 years, I have helped develop a lot of data pipelines here in Airflow. So once we started going into the initiative to integrate agentic components into our platform, using all of the experience that we had, we thought it would be a good idea to create this conversational layer called Vayu. So yeah, I'm really excited to present this today for you.
Okay. So what is Vayu? So let's start with that question. So Vayu is basically an AI assistant to interact with Airflow. Okay. So primarily at the moment, how do we interact with Airflow? So we have got this nice UI, which is from Airflow itself, with which we can actually see our DAGs with some clicks and things. We can monitor check logs, see some DAG fail, all those things is handled via a user interface. Another thing with Airflow gives is the CLI tool, with which you can actually type some commands and then see what's there in Airflow, what's happening with Airflow instance you've deployed, right? Okay, so those are the primary things, user interfaces at the moment with Airflow. And how do we alter Airflow data pipelines? Basically, you write some tags. So Airflow 3, previously it was Python, but recently you can have you can write your pipelines in any programming languages. But sometimes having a conversational layer where an AI assistant interface where anybody can interact with the Airflow in pure natural language, right? That makes a huge difference. So Vayu does that. So just for your information, Vayu, the name Vayu comes from a Hindu god who actually controls the wind, which is the essential, or air, which is the essential part of life, right? So that's about Vayu. So let's see how having a conversational layer becomes helpful, right? Why does the existing interface doesn't work or having a conversational layer is better? Okay. So if you are a data engineer, you might already be spending a lot of time if you are if you're managing data pipelines by Airflow and there are hundreds of pipelines, you might be spending a lot of time in troubleshooting pipeline phase, right? So even if you have unit test cases or pre-deployment checks to make sure my DAG won't fail or the pipeline won't fail, since Airflow is a generic workflow orchestration thing, it actually connects all other systems together, right? So it has got a lot of dependencies. So it has got a lot of runtime dependencies. Maybe you might be pulling something from database or triggering some Spark jobs. So there are a lot of external dependencies with which you will only know if something failed in runtime only, or actually when you execute the DAG only, you know there are something wrong. So Vayu is helpful to troubleshoot any issues. Let's say, so let me explain how a conversational layer makes a big difference. If you're coming to office in the car, if you're data engineer, you can just ask Vayu, hey, is there any DAG failures last day or something? So that Vayu actually analyzes underneath Vayu calls the Airflow corresponding APIs and then summarize things for you with LLM's capabilities. Right. Another thing is once you have identified the root cause, you may need to fix it. How do you fix it? You have to change or deploy the change. Usually, you will be version controlling your whole pipeline. So, Airflow support many things. So, GitHub, you can put version control things into GitHub. And recently in Airflow 3, there's this concept of DAG bundle where you can directly deploy DAGs from GitHub. So, yeah. So that is another thing. So say if you figure out an issue and how do you fix an issue? First, you pull the code into your local system and then you might be opening this into an IDE and then you might be doing some fixes. But simple small fixes, you don't need to do all of these things. Vayu helps here. So if you can actually fix those things and then it can create a pull request into GitHub, right? Another thing is sometimes you might be looking at any DAG which is written by some other data engineer if your organization is too big. So you have to go to the code and then see what happens. And if it's a too big DAG with a lot of tasks and things, it becomes very hectic. So you can just ask Vayu, hey, can you summarize what the DAG does? And then it actually basically does that. And it summarizes what the DAG does. Another thing is your pipeline will have a lot of configurations and variables and stuff like that, right? So you can actually manage these configurations because that is how once you define the stack, usually you will be pulling something from variables or Airflow configuration which actually controls the behavior of the pipeline. So I can manage that for you. Now, imagine all of these four things I mentioned being done by someone who is not close to Airflow and its internal logics. For example, since Airflow is a nice workflow orchestration engine, maybe data analysts might be using it for just maybe generating reports or running some SQL script daily or something. Or an ML engineer to fine-tune some LLM models, or maybe doing some inference, etc. Of course, QA is basically a typical example which we have at Prevalent AI. Since automating the quality of all the data pipelines, we cannot do that during the pull request or something because it's a lot of time-taking process. You usually have certain things automated for the making sure the quality of the pipelines are better. So our QA engineers here, you make use of their behavior-based test automation scripts being orchestrated completely using Airflow. So if you have Airflow already for data pipelines, why do they need to check for any other automation tool for automating their QA stuff? Another thing is, of course, DevOps. So these guys won't be not as close to Airflow as data engineers. So these things becomes having a conversation layer which abstract these logics from them makes a huge difference, right? So those are the key things where Vayu would be helpful. So with that, I will go into the architecture. So primarily in any agentic application. These are the left side here. These are the three layers or four layers you have. You have the UI layer, where it's primarily where the user will be. If you have a user to need to interact with this agentic system, you will have a UI layer probably. So in the Vayu's architecture is we are using a framework called Agent Development Kit from Google. Whereas a lot of things we choose Google ADK, which does a lot of things, which covers a lot of layers. At the moment, UI layer we have this ADK web, which Sajid will demonstrate. So, but ADK has its own REST APIs to interact with the agents, and then we can write our own interfaces, maybe some React backends, stuff like that, using this REST APIs which comes with ADK, and then orchestration and data layer. So orchestration layer actually orchestrate or serves the agent to the outside world as a proper web service or something, and then it also controls the LLM interaction. So agent is basically LLMs with the user interaction. It actually calls LLM actually using the LLM's reasoning capability, we will be calling out tools. So data means for every orchestration layer has to manage this conversations of thread to remember previous thing user has asked for. So data involves management of memory, sessions, and states, etc. So ADK abstracts all of these things for you, and that gives a nice wrapper with which you will be able to easily write your ACD closing. So that's on the orchestration and data layer. And then the LLMs, currently we tested Vayu with Gemini 2.5 Flash model. Plus we have tried our own, we have tried other models in AWS Bedrock as well. Okay. And then, so the advantage of one of the advantages of ADK is the LLM interaction is handled by a wrapper called Light LLM. If you have the tool calling capabilities plus reasoning capabilities, and then if you can actually try different models, you have to actually put those, specify that. And another advantage of that is since we will be having a lot of sensitive information, since it's actually data pipelines, right? Sometimes, so having your own LLM models, because you won't be ready to expose everything to the external on services, right? So sometimes you can host your own model. Maybe we are doing that as well, using VLLM based or some in-house models, some small open source model available. We try that. So, but make sure if you try any particular model, make sure you have proper reasoning and coding benchmarks for that model. So with that, and another layer is the tooling. So we have written two MCP servers, one for the interact with the GitHub for the pipeline mechanic agent, another one Airflow MCP server. Both we use a framework called FastMCP, which is a Python framework. You write model context protocol, so that tool calling is standardized across. So the reason why we had used in existing Airflow open source MCP servers because we couldn't see proper documentation and things for those, and then we thought of writing our own thing because we have to make sure the tools are properly defined for matching our use cases and with proper documentation and things for LLM to understand, right? And also GitHub MCP server, we tried the GitHub, remote GitHub MCP server, which is available, but there were some issues, and then we thought of writing our own GitHub MCP logic because fast MCP, writing an MCP logic is very simple, right? It has a lot of nice framework thing implemented so that you can easily write MCP server, right? And then the actual tool is being called to the execution or the end tools, which is Airflow or GitHub in this case. So that's pretty much about the architecture. With that, I will hand over to Sanjit. So let's see Vayu in action.
So without further ado, let's just get right into it. So let's use Vayu. So like Irshad mentioned, like the whole goal for Vayu is so that non-data engineers, so people who are not that familiar with writing and debugging Airflow, can use this and use simple natural language to to fix issues. So over here, I have an Airflow cluster, an Airflow deployed, and this over here is my chat interface. So this is where I'm going to interact with Vayu. So again, you can try some very simple queries, and using the tools that we have defined, you can get a lot of information. So let's say that I'm an analyst. So I'm going to be talking from a data analyst point of view, where I have been given a DAG from a data engineer from another team to run some analytics. So this is a DAG given to me. So maybe first I can go ahead and ask, like, what does the DAG student database pipeline do? So we have actually defined a few sub-agents for Vayu, and one is the DAG troubleshooter agent, which actually is involved in troubleshooting and analyzing code and, checking for configurations and seeing if there are any mismatches. So here it's read the DAG file, and it's given me what the task actually does, and it's even given me a nice good summary. So maybe I see that it's going to set up a student database, populate it with some data, and run some basic SQL query. Obviously, the simplified DAG is just for demonstration purposes. So let me just go ahead and trigger this one. Let's see what happens. So as you can see, this task has failed. So again, instead of going ahead and trying to do a lot of manual work, let's go ahead and ask Vayu. So I'm going to say the most recent DAG run for this DAG has failed. Please analyze the root cause for it. So again, Vayu delegates this to the DAG troubleshooter agent. And actually, if you can see here, if you go into the logs, you can see that it is actually caused by an SSL certification error. So we expect Vayu to say this. And again, this is like a classic example of, as you can see, Vayu has given this error. This is like a classic example of where a developer can actually unit test their pipelines for up to 80 or 90% coverage, but environment specific issues like this can always pop up. So it's actually even shown me clearly what the error is, what the impact is. It has given me possible solutions. And it has also asked me whether I would like to disable SSL verification for the student API connection. Now, why has it done that? It already knows the code. It knows that it takes the API call from an Airflow connection. And it has already asked me whether I want it to disable verification. So yes, I'll go ahead and ask it to do that. And if you can see, the student API connection here does not have the SSL verify given here in the extra section. And what I expect is Vayu to do it. So okay, it says that it cannot do it. So let me maybe ask it to try again. Again, I just want to reiterate that, this having an AI component involved, as always, can cause a little bit of hallucinations. So it says that it cannot modify. So let me just go ahead and modify this myself. Oh, actually, it did modify apparently. So my bad. I think this is what Vayu not really actually doing the task, but not exactly telling me that it's done it. So when I can see here that the extra parameter has been given. So now maybe I can ask Vayu to retry. I can ask it to clear the failed task instance. Let's see what it does. Now, again, we have a lot of tools that can do each of these functionalities, like clearing task instances, listing variables, editing connections. So the edit connection part is what you just saw here. We've also given it tools to analyze DAG code. Okay, so it's asking me the DAG ID and run ID. So let's get a bit more specific here. I have this DAG run over here. Let me just go ahead and paste this. This is the DAG run. Let's see if it actually clears it. Okay, so it is given it to the Airflow metadata agent. So this is again another agent which we have defined as part of our Vayu pipeline. Okay, so it's asking me for confirmation. Let's just say yes. Now, again, the reason, if you're wondering like why we are doing this, by the way, it is it's Vayu is automatically cleared in. We have got the logs and all of this. So again, this can be useful for a data analyst or even a QA engineer who is not familiar with this. Now, let's just try one more case. So I see that here I have a task that runs some analytics, and I can see when I go into the logs that it's running an SQL query. So I want to know where this task actually gets the SQL query from, let's say. So I'm going to just copy this task name, and I'm going to say, where does the task of the DAX student database pipeline get its SQL query from? So we have the DAG troubleshooter agent in work. Okay, so it's given me an answer. It says that the source code is the SQL query is currently hard coded. Okay, so that doesn't sound very ideal. And it also says that the documentation within the DAG states that the SQL query is supposed to be taken from an Airflow variable named student query. And it's asking us to, it says that we need to do the code changes, set the student variable. Okay, this sounds pretty reasonable. So let's say let me prompt the chat. Let me prompt Vayu to create the Airflow variable for the same. Now, I don't have any Airflow variables here, but apparently what happened is when the developer gave the DAG, he actually hard coded the value instead of actually taking it from a variable. So it's saying that I'm asking it to create an Airflow variable, modify the source code. So it's going to first create the Airflow variable. So I'm going to say, okay, it wants me to know what the SQL query will be. So let me just go ahead and give the same query for now. You can give any query you like. And I just hope that from this you can see how we can simplify a lot of stuff. So okay, so yeah, so now it's going to ask me to okay, so it's again asking me for a confirmation. Okay, so let me just say yes, create the variables first. We have not given Vayu too many freedom to actually execute stuff without our confirmation. So I guess that is why it's asking us again and again. So now, as you can see, the variable has been created with the query that I provided. And now it's going to ask me, okay, so it says that this change will, the code, now it's going to prompt me for the code change. So it's asking me whether I want to update in my code to take it from the Airflow variable. So yes, I'm going to say, implement this code change and push the changes to the GitHub repo via. So we have not actually, like Vayu is mentioning here, we have not provided the capability to modify the DAG code in the environment. Rather, we are delegating the control to actually commit this to GitHub, and then maybe a data engineer or someone who is aware of the code can actually come in, check it, merge it, and then deploy it using your deployment pipeline. So this is a test repo that I've just created in my own personal GitHub account. And this is the only file that is there. So over here, as you can see, the task actually takes a hard-coded SQL query. Probably a mistake from the developer, but Vayu has helped us identify it. And it's also said that it's created a pull request and the pull request is 19. So over here, we have the pull request. It's just been opened now. And as you can see, it's done a pretty good job of documenting what the change is. And it's changed the hard-coded value to consume it from the student query variable, which is what we just created. So I hope this just gives you an idea how easily someone who does not have much knowledge about Airflow can just come, use normal natural language to just do a quick fix, create variables, maybe change connections. And you can keep adding a lot of tools to Airflow and to this GitHub MCP server. as you want more workflows and more use cases. So I hope you have an idea from this demo. I'll hand it back over to it.
Okay, so that's Vayu in action. So let's see what are the next steps, right? So as I mentioned, this is just a prototype, and then we have the source code open source. You can just search Vayu the Airflow Copilot in GitHub. It is there. We have all the things which we covered here as there in the protocol. So that as next steps, we are keen to add a little bit of security into this thing, because in an LLM application, security is the most important thing which we need to care. So we have to integrate maybe a Docker-based authentication from the UI itself, so that we can track things across to the whole ecosystem itself. At the moment, we just configured a Docker repository at a GitHub token. Security is the key thing, because we need to have a proper AI governance things, so that all the things and stuff is properly monitored, and we have proper monitoring things, logging, all sort of things. So we need to focus on security first a little bit, and then another thing is state and memory persistence. At the moment, we are just making use of the inbuilt services from ADK, which actually persists things in memory. So even if you restart the server or something, the whole conversation will be lost. So there are certain services, like some services available to persist things into relation databases or Redis or whatever. So we can write our own services as well in the Google ADK. And another thing is LLM token optimizations, which we want to build, because since it's involved in sending on the logs and all, we need to make sure the context window is in such a way that we are not sending too many things into the LLM, only the most required things. So some token optimizations has to be done. Another thing is integration to Airflow 3. Currently, it's supposed to Airflow 2 and 15. And 3 has got a lot of API changes. We have to keep implement those in the MCPs and the ADK. And then another one is as we just saw, we are just making use of the GitHub MCP. But Airflow 3 has a nice feature of DAG builder concept, where you can actually directly link things from GitHub directly. So we need to make use of those APIs instead of an MCP server to upgrade pipeline mechanic to use DAG button. Another key important things, I want to make this integrated into the Airflow UI. So I don't want to log into different things for interacting with Vayu. So I need to have a Copilot kind of button in Airflow UI, so that if I click, I can see the tab and I can actually interact with Airflow UI itself as a Copilot mode kind of things in the GitHub Copilot and Microsoft Copilot, etc. So luckily, Airflow 3 has got a lot of recent advancements in the UI, because it was using a Flask app builder based old UI thing. Now they are modernizing the UI, and I've seen in the 3.1 now they have recently has a capability to actually write our own React plugins. Right, I need to try out that. So these things are open to the community for the pull requests. So yeah, so those are the key next steps which we think we need to focus on. Yeah, I think that's all from we need to cover.